Okay, so second question from the conceptual section of an introduction to statistical learning. It's a mouthful. So this is from chapter 3, and here is the question. So we are meant to explain the differences between the KNN, or K nearest neighbors classifier, and KNN regression methods. Okay, and so I've written a little difference here. So but generally, so KNN, just so K nearest neighbors, just refers to a method where we are using the K, where K is some number, nearest data points in the predictor variable space to estimate an outcome. Okay, and so when we are doing KNN classification, so that looks like this first image right here. We have our data that ahead of time we have said, well, these data points over here, I know that these are blue data points and these ones are red, and then so we've trained the model, and then after we train the model, new data points get assigned to one or the other based on their proximity to these clusters, again in predictor variable space. Okay, that's classification. So how does classification work? So we are using the K nearest data points in predictor variable space, and then we are voting. We are using a majority classification. So this data point, let's say that we were taking the nearest, it's kind of a bad example, but let's say that we were taking the nearest 10 data points, or I don't even know if there is that many, but the 10 nearest data points, most of those would be here in the blue. Just a few of those would be in the red, and so there would be more blue that were closer than red to that data point, and so it would be classified as blue. So it's just a majority rules, and the outcome for KNN classification is a classification, blue or red in this case. Okay, so KNN regression is a little bit different. So again, we're using the nearest data points in predictor variable space. Okay, but now but the way that we are assigning the outcome, now the outcome is now a quantitative estimate, so it's a number, right? So here's regression. So a value for the predictor variable here, x, would be some variable between, or some value between 0 and about 4 on the y-axis. Okay, that would be the outcome. And the way that we're assigning the value, or predicting the value of y, is now going along the x-axis, finding our data point, finding the closest data points, and then taking the arithmetic mean, generally, or I guess you could do the median or whatever, but some average value, some value of central tendency for that data point according to its K nearest neighbors. So that's the difference. Okay, thanks.